Hi everyone. I'm going to try to keep tonight's notes brief, but please keep in mind that to receive full credit for your notes, you need to make sure that you include 3 questions based on the material covered within this video. They will either be questions that you genuinely have from watching the video, or they'll be questions that you're going to create based on the information in the video. But for full credit, you need to have 3 questions along with the information covered in the video. All right, so we've been talking about how to graph a circle, the equation of a circle, and tonight we change gears and we are going to start talking about the angles and the pieces of circles known as arcs. So first of all, we have a central angle. And a central angle is exactly what it sounds like. It's an angle whose vertex is on the center of a circle, like we have here. Okay. We also have what are known as um, oh, I'm sorry. I should say before we move on that a central angle is labeled or named the same way we would name any other angle. We take one side, trace our finger to the vertex, name that point, and then trace it down along the other side to the other endpoint. So this central angle could be called angle AOB or angle BOA, either one. Circles, by the way, since I haven't mentioned it, are simply named with the single letter of their center. So we would call this circle circle O. And we literally just use a little circle, a little circle like this, like a little symbol of a circle, and then we put the letter of the center, like O, for example, or B, or whatever it's going to be. So this one would be called circle O, like we said. Oopsie. Don't want to move that around. So I'm going to get this guy up here. And we usually put a little dot inside of our circle symbol. So that's how we would name a circle. Okay, so moving on, a central angle is named the same way we name any other angles. And the other part of the circle we're going to talk about tonight is a segment of the circle or a piece of the circle called an arc. Okay, arcs can come in a bunch of different sizes. They can be big, and we're going to define big as bigger than 180 degrees. Arcs can be small or less than 180 degrees, or they can be exactly half the circle or equal to 180 degrees. So we call the big ones major arcs, and we name our arcs with 3 points similar to the way we name angles. So we start with an endpoint of an arc. We have to pick a point somewhere in the middle of the arc, anywhere in the middle of the arc, and then the other endpoint of the arc. So arc ACB would be this entire part of the circle from A passing through C all the way to B. Semicircles we name exactly the same way. We start with an endpoint. We name any point within the middle of that semicircle all the way to the other endpoint. And finally, arcs can be small, and they're called minor arcs. And minor arcs are the only arcs that can be named with 2 points only, just the 2 endpoints. Okay. All right, so we've got angles and we've got arcs, and how are they related to one another's? Well, central angles, in case you hadn't noticed, intersect the circle and create what we call intercepted arcs. So angle AOB right here created a minor arc AB, also known as BA. The takeaway, the one piece of information you need to know about this relationship is that central angles and their intercepted arcs are always equal. So if this central angle is 60, then arc AB has to be 60. So we're going to use that to solve problems involving pieces of our circle. One thing that we should keep in mind is that an entire circle, its central angles will always add up to equal 360 degrees. And similarly, because the central angles all have to add up to equal 360, the measurement of the arc in degrees will always add up to equal 360 for an entire circle. So a semicircle will always have an arc measurement of 180 degrees, Okay. Similarly to the angle that is intercepting it would be a straight line, and that straight line would have a measurement of 180 degrees. So again, the central angle measurement always equals the intercepted arc measurement. That's what you need to know. Make sure that you jot down any questions you have, and I'll see you guys in class.